Welcome you all in the another lecture of Structural Analysis 1. I am Mr. Aasif Baig, Assistant Professor Civil Engineering Department, Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. So friends, here we are with the numerical of 3 consecutive beam which we have to solve under 3 moment theorem or Clapeyron's theorem. So before going into this lecture, if you go through the first part of this lecture, that the link which is I have pasted in the description, the concept will be clear to you. Okay, so here is the numerical of having A, B, C, D support, having 3 span. AB span consists of eccentric concentrated load of 100 kN situated at 1 meter from A, B and 3 meter from B, over the span of 4 meter having moment of inertia I. BC span having a UDL of 40 kN per meter over the span of 4 meter and having moment of inertia 2I. And CD span is subjected to the eccentric concentrated load of 80 kN situated 2 meter from D and 3 meter from C over the span of 5 meter having moment of inertia 1.5. Okay, so before starting the numerical, first step is to draw the bending moment diagram. So in bending moment diagram, we know for eccentric concentrated load, the bending moment value is WAB by L, and we have to draw this in first degree curve. Okay, so for first degree curve, it will be drawn like this. Okay, the value is WAB by L. Then BC is having UDL, uniformly distributed load, so it is in the shape of parabolic. This is technically called as second degree curve, so it is WL square by 8. And the third one is again it is eccentric concentrated load, so it is again WAB by L. So it is WAB by L. So if we add if we substitute the value of W 100 kN, A 1 meter, B 3 meter and L 4 meter in this equation, we will get the value of bending moment 75 kN meter for the first span. Now if we add or substitute the value of W 40, L 4 meter divided by L square by divided by A, we will get the bending moment as 80 kN meter. And if we substitute W 80 kN, A 3 meter, B 2 meter and length 5 meter in the third span, for the third span, we will get the bending moment as 96 kN meter. Now for analyzing with the 3 moment theorem, we have to apply the 3 moment theorem for first for 2 span, then again we have to apply the 3 moment theorem for second 2 span. Why? Because if you look into this beam, we having A, B, C, D are the hinge support, but at A and D these are the end support, and due to which the moment at A and D will be 0. But there will be moment at B support and C support. Moment MB, moment B will be there and moment C will be there, as these hinge support are the intermediate support. And due to which there are 2 extra unknown in this beam, and due to which we have to apply 2 times 3 moment equation. So first we will apply 3 moment theorem for A, B, C, and we will form one equation having moment MB and MC. Equation number 1 will be there, and then we will apply 3 moment theorem for span B, C, D, in which equation number 2 will be formed where MB and MC will be there. Okay, and we will then equate both the equation to determine the moment B and moment C. Okay, so start with this applying 3 moment theorem for span A, B, C. So for the sake of easy in the calculation, we will draw the bending moment diagram of first 2 span. Okay, so A, B and C. The first one is the eccentric load, the value of this is 75, and the second one is the UDL having the value of 80 kN. Okay. Now we have to calculate x1 bar, that is the CG of the bending moment diagram of first span from left support, and x2 bar, that is the CG of the bending moment diagram of second span from right hand side. Now we have to write the equation of three moment theorem, and that is MA L1 by I1 plus twice MB L1 by I1 plus L2 by I2 plus MC L2 by I2 is equals to minus 6 A1 x1 bar divided by L1 I1 minus 6 A2 x2 bar divided by L2 I2. Now what is given to us and what is we have to calculate from the given data, that we have to see. So MA L1 by I1, as is the moment MA is 0, so we have to make this as 0. Now moment MB will be there, as this is the intermediate support, and MC will be there also because this is also intermediate support. So MB and MC will be there in the equation. L1 it is given as 4 meter, L2 it is given as, again it is 4 meter, I1, the value of I1 is 1I and I2 is 2I. So substitute all these values in this equation. We have to calculate A1 and A1, A2 and x1 bar and x2 bar. So A1 is nothing but the area of the bending moment diagram of first span, and A2 is the area of the bending moment of the second span. Okay, so for the calculation of A1, as it is a triangular shape, so the area of this is half base into height. So half, the base is 4 meters into height is 75. So 1 by 2, that is 150 kilonewton meter square. So why this is kilonewton meter square? I have already told this in the previous lecture. Kilonewton meter is the unit of this 75, and this is the bending moment, and this is having the unit of meter. So this becomes kilonewton meter square. Okay. Now area 2 is, that is parabolic shape. So this is 2/3 B into H. So 2/3 base is 4, and the value of H is 80. So this is equals to, so the value is 213.33 kilonewton meter square. Okay. So as we are only taking this ABC span, so we will not calculate the area 3. So this area 3 we will calculate in the second, when we will apply this 3 moment theorem for second time. Okay. Now we will calculate x1 bar. So x1 bar, as this is the x1 bar, and this is eccentric point node, due to which this triangle is of having unsymmetry shape. So this is L plus A by 3. So the value of L is 4, value of A is 1 divided by 3. So this is 5 by 3. So this is 1.67 meter. Now the value of x2 is, this is parabolic shape which is having symmetry. So this will be L by 2. So L is 4 divided by 2, that is 2 meter. Now put all this value into this equation, and we will get one equation having MB and MC. Okay. So 2 MB, I think, is it visible on the screen?
Yes.
2 MB L1 is 4 divided by I plus 4 divided by 2I plus MC. L2 is 4 divided by 2I is equals to minus 6. Value of A1 is 150 kilonewton meter square and X1 is 1.67 divided by L1 is 4 and value of I is 1 minus 6 into this is 213.33 into 2 divided by 4 into 2I. Now if we calculate this value, so first we will cut this value with this one. Only I value we have to put out, not this 2I. So this 2 will be in the calculation. Okay. So 4 by 2, this is 2. 2 plus 4 is 6. 6 into 2 is 12. So 12 MB plus 4 by 2, 2 MC. 12 MB plus MC, and whatever we do the calculation of this, we will calculate it and we will write this in the equation form. So I am directly writing this. Directly I have calculated in my notes and I will write it. So I am writing the calculation of this here due to the short of the space. 12 MB plus 2 MC is equals to minus 695.75. So this is the equation number 1. Now to calculate the moment B and moment C, we have to calculate the second equation by applying 3 moment theorem for span BCD. Okay, so second equation will form and we will equate this equation to calculate MB and MC. So we will write this equation somewhere else and we will remember this equation while calculating the MB and MC. Okay, so now we are applying 3 moment theorem for span BCD. So for sake of easy calculation, we will draw this bending moment diagram of span BCD. So BCD first span will be now this BC span having moment of inertia 80, and the second span will be now this CD span having moment of inertia 96. Now here x1 value will be from the left side. Okay, this one will be the x1 value and x2 will be this one. X2 bar will be now this one. So applying 3 moment theorem for BCD, so I am writing with this notation MB. Now keep remember this is L1 for us now. So this is L1 divided by x1 bar plus twice MC we have to keep here right here. L1 divided by I1, sorry, this is I1, not x1 bar, I1 plus L2 divided by I2 plus MD L2 divided by I2 is equals to minus 6 A1 x1 bar divided by L1 I1 minus 6 A2 x2 bar divided by L2 I2. So now we know that MD moment D will be 0 because D support is the end support. So this we have to make as 0 and we have to write MD value and MC value with this L1 and I1, L2 and I2 values. We have to calculate A1, A2, x1 bar and x2 bar. So A1 is for this diagram. So this is we have calculated already. This is 2/3 into B into H. The value will be same. So I am directly writing this 213.33 kilonewton meter square. Value of A2 will be, that is triangle, so half base into height. So base is 5 meter, half base is 5 meter and height is 96. So the calculation of this is 240 kilonewton meter square. Now x1 bar is, this is from left side x1 bar, so again the value will be same as the diagram is symmetry, so L by 2, that is 4 by 2 is equals to 2 meter, and x2 bar value is from this side, so this is L plus B by 3, so L is 5, B is 2 meter divided by 3, so this is 5 plus 2, 7 divided by 3, that is 2.33 meter. Now put all this value into this equation, we will get the another second equation with MB and MC. So MB, L1 is 4 divided by 2I plus twice MC. L1 is 4 divided by 2I plus 5 divided by 1.5I, because this CD member is having 1.5I moment of inertia, plus MD is 0, so no need to write the value of 0 there, is equals to minus 6. The value of A1 is 213.33 into 2 divided by 4 into 2I minus 6 into the value of A2 is 240 into x2 bar value is 2.33 divided by 5 into 1.5I. Okay. Now if you calculate this value, we have to first cancel this I value with this I. Okay. And we have to keep this value as it is 2, 1.5I, 1.5I. This value we have to keep as it is in the calculation part, and we will form the another second equation of consists of MB and MC. So if you calculate this value, you will get the equation 2MB plus 10.66 MC is equals to minus 767.35. This is the second equation. Now this is what the second equation we got from this equation. We have get the first equation by applying three moment theorem for ABC span. We will compare that one equation with these two equations. We will equate this equation. We will calculate MB and MC. So by equating equation number 1 and 2, we will get the value of MB and MC directly. So I am writing that MB and MC value directly on board. Now by equating equation number 1, equation number 1 and equation number 2, we will get the value of MB and MC as minus 47.40 kilonewton and minus 63.07 kilonewton meter. So this minus sign shows the anti-clockwise moment. So we will draw these bending moments on the final bending moment diagram. So for final bending moment diagram, first we have to draw this free bending moment diagram. So this is we are drawing here free bending moment diagram. This is 75. This is 80 and this is 96 kilonewton. This is free bending moment diagram, and we have to draw this moment B and moment C in this. Always remember, while drawing this bending moment diagram, keep remember that if the bending moment is negative, you have to draw above the line. If the bending moment is positive, you have to draw below the line. These things you have to remember only in this three moment theorem, only in the analysis of beam only. Okay. Now moment A is 0, we know. Moment D is 0. Moment B is having value of minus 47, so we are drawing above the line minus 47. So only write 47.6340 without sign, because we have considered this with the anti-clockwise direction. So we have to connect this with this 0. Then another value is minus 63.07. So minus 63 is above this. So this we have to connect this 63.07 and we have to join this with this 0. So this is what the final bending moment diagram. So this is what the final bending moment diagram of three span A, B, C, D, where we have apply three moment theorem for two times, for span ABC and for span BCD. Okay. So with this, I declare this topic at the end. Thank you.